Hey guys, this is to be a quick review, not a full lesson because we already covered this, but a quick review of relations and functions. So some things that we're going to focus on. What is a relation? How is a relation not a function? Not every relation is a function. Hopefully you remember that. Describe domain and range and being able to do so with the appropriate notation. So essential understanding, a pairing of items from two sets is special if each item from one set pairs with exactly one item from the second list. So we're talking about a special set over here. Okay, the special one that we're referring to right up here is going to be a function. This is essentially the definition of a function. A relation is a pairing of items from two sets. So if I wanted to do a little color coordinating, and if you wanted to follow along in your notes and also color coordinate your notes, I would say that we would look at a pairing of items from two sets. Okay, that part over there, I know it's a little hard to see, but that part over there is just non-special, sorry to break it to you, non-special relations. Those are just plain old relations. So my relations I'm looking at over here, focused in purple, okay? If you can kind of tell that is purple. Now, it is special if each item from one set pairs with exactly one item, no more than one, from the second list or the second set. So that down on the bottom of the page, not bottom, but towards the middle, you'll see function relations. It's all example 2. Example 2 focuses on functions. Example 1, non-special relations. So just plain, boring relations, nothing special about them. We have a little bit more of a definition of a relation right over here. It says a relation is a set of pairs of input and output values, okay? A relation is a set of pairs of input and output values. I really hope we all remember what an input and an output is referring to. Do you remember? Input is the what value? Output is the, which one? Input is X, output is Y, okay? Input is also known as the what? Independent. Output is known as the what? Dependent. From here, we see that there are 4 ways to represent a relation mentioned. But I know in class, we did talk about that there were 5 ways. So right now, 4 ways to represent a relation are highlighted in this lesson. So I'm going to focus on 4 of those 5. The 5th option, equations, develops throughout the course. So it is going to be the hardest one for you to wrap your heads around in the beginning, is dealing with equations, because we don't know a lot about their graphs yet. But the other 4, set of ordered pairs, mapping diagram, table of values, and graph, we're just going to review right now. So this first example, example 1, non-special relations. So just a regular relation. Could look anything like any of these. So really, functions are relations as well. Both of these are relations. The ones on bottom are special because they are function relations, because they meet the definition described before, okay? So this type is special, not special, sorry. The ordered pairs I have listed, 0, 4, 3, 0, and 3, 2, are listed in a set of ordered pairs. When you use set of ordered pairs, that is different than set builder notation. I don't know if everyone knows the difference. So a set of ordered pairs, yes, you will have the curly brackets on the outside. But you will also have, think about it, it says a set of what? Ordered pairs. Inside, you're listing ordered pairs. So you will have an X value, a Y value, in parentheses, comma, another X value, another Y value, close the parentheses, and so on until you fill it up. These can't be the same. I wouldn't list the same ordered pair twice. That's silly. So you might use subscripts. 1, a 2, and this, or no, I'm sorry, not a 2 there. A sub 1 on both of these, okay? So let's just spit it a little nicer. Okay. So this might be X sub 1, Y sub 1. Then this will be X sub 2 and Y sub 2, dot, 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 to indicate more, okay? Pay attention to the words. Set. The phrase set tells you, hey, I'm going to need those curly brackets, okay? Of what? Is it a set for the domain? Is it a set for the range? Or is it a set of ordered pairs? This is a set of ordered pairs, so that's what we list in here. The same ordered pairs are listed right here. My input values are my X's, so I have 0, 3, and 3. I don't list a value more than once when you're doing a mapping diagram. Your mapping diagram, things that you lost points on the quiz. You're going to have a big test grade coming up, so you want to make sure you do things correctly. A mapping diagram, you must have an arrow pointing from the input to the output, or from the X to the Y. An arrow, okay? Only pointing towards the Y, because we are looking at it going from one place, the input, to another place, the output. You also need to have labels. You cannot just have random information. You label your input and your output. You can call it domain and range. You can call it X and Y. Commonly, we like to use input and output, so try to use that. Also, you need to list your values in order. from least to greatest, from least to greatest, okay? So if you meet all this criteria, then you make a mapping diagram, well, then you could pretty much guarantee you'll get full credit for that question. Table of values is quite similar, but you would repeat a value. Side by side, you see your ordered pairs. There's 0, 4. Here's 3, 0. And here is 3, negative 2, okay? And then my graph on the side. Just to kind of point out a few things. So here, 0, 4. Here is 0, 4. There is 0, 4. Ordered pair. Some of us don't know the difference between 0 first and 0 second. So 0, 4, pay attention to where it lands, okay? Move over left or right 0, up and down, you're going 4 units, okay? Hopefully these colors aren't going to be too dark. The next one over here, 3, 0, just because, again, I don't want to have to take points off for silly things. Here's 3, 0. Here's another representation of 3, 0. And then that would be my x-intercept as opposed to the last one, which was my y-intercept, okay? Next, I have 3, negative 2. I think this blue highlighter I'm holding is a little dark. Let me grab this one maybe. Okay, so 3, negative 2. Now, it's going to be a little funny to do that because I'm overlapping, so a little gross, sorry. 3, negative 2 right there, and then again, right 3 and down 2. So there's the other point, okay? Make sure you're able to plot your points correctly because that seems to be a struggle for some people. All right, back down here. Now, in purple, we talked about our relations. In bright yellow, we have our function information. Functions are special relations. Each item from one set of pairs with exactly one item from the second list. That's the information we talked about from above, okay? How are they different in our representation of the relation? Why does it look different? How can I identify it right away? So let's just take a look. Sorry, I'm zooming out a little bit so we can see both at the same time. So again, I have a set of ordered pairs. Now here, I'm going to kind of use some of the similar colors here. In the set of ordered pairs, I have 0, 3, okay? Well, 0, 3 is 0, 3, right over here. In my table of values, it's right over there. And in my graph, it's right over there, okay? So there's the point, 0, 3. Next, the next point I have is, let's do, sorry, I'm just digging out the colors that are going to show up nicely. I guess I'll try the orange. I really like the orange. Oh well. 1, negative 3, 1, negative 3, 1, negative 3, and 1, negative 3. And my last point for right now. Now, this doesn't mean they're limited to being just 3 ordered pairs. It's not how it works. You could certainly have more than 3 ordered pairs. You could have 2 ordered pairs. You could have 10 ordered pairs. Whatever. It really doesn't matter. Yeah, I don't know what other colors will show up. Sorry, I'm digging, but 2, 0, 2, 0, 2, 0, and 2, 0. So what do we notice? Okay, even if I didn't tell you, what are the big differences? Well, here, if you notice, I don't repeat any of my x values. I have 0, I have 1, I have 2. Here I had 0, 3, 3. How do you indicate it in a mapping diagram? Here, I have 2 lines coming out of the same x value. Here, that never happens. 0 uniquely goes to 3. 1 uniquely goes to negative 3. And 2 uniquely goes to 0. Now, that doesn't mean that it's going to be something we call 1 to 1. We'll talk about that in a second, okay? Here, again, no repeats of my x's. Graphically, okay, you can tell if something's going to qualify as a function if it passes a test, and hopefully you all remember the name of the test, okay? Test was called what? The vertical line test, okay? So vertical line test, I'm going to abbreviate VLT, and we'll talk about that shortly. Next, domain. So we have domain and range. Domain I refer to as a girl, and range I refer to as a boy, x's and y's, whatever. So you may remember some of that. So what can we talk about? So I'm just going to lift this up. We're going to do examples. I'm just kind of powering through these definitions. The domain of a relation is the set of inputs, also called x-coordinates, of the ordered pairs. If this is news to you, then you haven't been paying very close attention. All right. Next, the range. The range. Ooh, I don't know how I feel about this. It's a little too dark. The range is the set of outputs, also called y-coordinates, of the ordered pairs. I guess it's okay. Okay, so I'm going to color coordinate. That's my definition. Range of example 1, range of example 2. Those are going to be domains. What else can I kind of highlight over here? Well, range went with the y value, so I'm going to go over here above. I'm going to go into both of these, okay? So I'm going to underline all of my y values or things connecting to my y values. So maybe I'm going to kind of outline this little cloud over here in blue because that's what I use for the range. Here again, I have output listed or y. I don't know how clearly that's showing up, sorry. Or our y-axis. again, your y coordinates. Okay, where are they? Well, it's that one, and that one, and that one. Kind of hard to see, sorry. And then what about our domain in pink over here? So domain, down on bottom, I'm going to highlight that in pink. Domain, maybe you have crayons highlight or something, and you're going to kind of color coordinate as well. Okay, so domain, I'm doing pink. Up here, I should have gone up one more example. You could do example 1 also. Here's the domain, the x's. It is my input, so maybe I'm going to trace this a little bit. And here's the input for the x. And here I have it's my x-axis. What are my x coordinates? I have that guy right there, this one over here, and this one over here. And it's a little tricky to see on these, but that's for my domain. So I did example 1 already. It looks a little funny, but example 1 is going to be above the line I'm about to draw. So I'm going to draw a line over here, okay? So domain of example 1. And I said the domain is 0, 3. It really, 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 really matters if you draw this nice curly bracket, or, see, set notation, or if you wimp out and use parentheses or just square brackets. If you do not use these curly brackets, you are wrong. It has to be the curly brackets. The set is listing individual pieces, individual items as a list. It is not saying you start here and go until there. So looking at example 1, the only x values, my domain, consists of 0 and 3. No one else. 0 and 3, 0 and 3, 0 and 3. That is the domain of example 1. The range of example 1, I have -2, 0, 4. Here, 4, 0, -2. Not in order, but I got it in order down there. -2, 0, 4. -2, 0, 4. -2, 0, 4. The y values, okay? So I could see my function relation example 2. I want to find the domain and range of that. So domain, I'm going to use set builder notation again. The domain is going to consist of the set of inputs, or x coordinates, of the ordered pairs. So my domain in example 2 is 0, 1, and 2. It looks like that's in order, so we are good with that. The range, 3, -3, and 0. Well, it's not in order, so I'm going to fix that. So it's -3, 0, and 3, and close off your bracket right there. So those are my domain and my range for example 2. What's the difference? Here, I had a repeat. I didn't list it twice, even though I had 3 ordered pairs. So it looks like I only have 2 x values in my domain. Okay? This is a dead giveaway that it won't be a function. If I only have 2 x's and 3 y's, I have fewer x's than y's, well, something's got to go on here where an x is being used twice, at least twice. Okay? So notes on domain and range. When is set notation appropriate? You could fill some stuff in here yourself, or we will talk about it when we're in class together, okay? So we will continue to talk about that. I just forgot to color this over here. Okay, so if you look, I'm just going to zoom out a little bit, okay? My notes are color coordinated, things make sense. I've read over them. They're not just here for no reason, okay? They need to serve a purpose. I need to look at them and use them and implement them into things that I'm going to be doing in the future, okay? Another thing that we already know, because we are a bit ahead, we're just going backwards here. We're kind of spiraling back around. The notation is going to be f of x when we start dealing with equations. So it might be helpful to remember that notation, okay? So now let's look at the next page. All right, let's kind of talk about how we're going to do these examples. Practice set 1. Determine if the given relation is a function. So basically a yes or no question. Is it a function? If you want to write yes or no, it means yes, it's a function. No, it's not. Or you could just write function or not a function, whatever you'd like. B, explain why or why not. Give some sort of support. Don't just state an answer and move on. Give some sort of supporting information. C, describe the domain and range with the most appropriate notation. So right now, look at what we're working with. Same stuff as the page prior, okay? So that means you're probably using set builder notation for your domain and range on this page. Remember, in domain and range, you do not repeat values if they're used more than once, and you do list them in order from least to greatest. Okay? We talked about how to tell if something's a function or not. So if you guys want to go ahead and press pause, you can work on these, give yourselves a few minutes, and when you're ready, press play again, and you can check your work. Okay? I'm assuming that you are back from being paused and that you tried this on your own first. And if you had it already done, well, good for you. Amazing. So number 1, is this a function? I'm going to go ahead and say, yes, this is a function. And I'm going to say it passes the vertical line test, okay? No x values are used more than once. You have to go back and double check your definition. Functions are special relations. Each item from one set pairs with exactly one item from the second list. The second list is the y values. Okay? The one set that we start with, those are your x values. Okay? So, yes, it's a function, passes the vertical line test. Quick way to tell. No x's are used more than once. Domain, go from left to right, okay? So from left, -4, 0, and 5. Range, we go from the bottom to the top. If these are things you need to write down, write them down. That's how you go from least to greatest, from bottom to top. So I'll have -5, 3, and just 3. Okay, this example is different than what we did before. We only have two y values, and it is a function. Make sure you take note of that. Next, looking at my x's, I have 6, 8, and 1. Is it a function? Yes. How do I know? No x value is used more than once. Essentially, that's how we're going to tell. Domain, make sure we go least to greatest. 1, 6, 8. That's it. X values, and you're done. Range, y values from least to greatest. So looking carefully, I had 1, 7, and -1. So -1, 1, and 7. Okay, here we have another example. I have my input-output. I have a mapping diagram. This was a set of ordered pairs. That was a graph. Is this a function? Quick way to tell. Well, first of all, don't forget, mapping diagram is a title on each column or each separate box. Don't make it a table. It's not connected. It's never connected. It has an arrow and a label, okay? How do you tell quickly by looking and glancing at a mapping diagram if it's a function? Well, if any x value has more than one arrow coming from it. Well, look right here. 1 has 2 arrows and 5 has 2 arrows. So is this a function? No. 2 x values, 1 and. Do not use a plus sign for and. 5 have more than one, use a little greater than symbol, arrow. That's good enough reason for me. As long as you know what that means. Domain, x is from least to greatest. Usually in your mapping diagram, it should be given to you that way. So -9, 1, 5. And then the range, again, it should also be in order already. Least to greatest, those are all negative, so it's good. -7, -2, -1, and close. Is this a function? X's, do they repeat? They do not, so yes. No x value repeats. Try to spice it up. Change your language, your reasoning each time, okay? Domain, from least to greatest. -27 is the least, -17, and -7. Range, well, only got one number, 100. That is it. Done. All right, how about these next These next 4 examples. Is this a function? No way, not at all. Fails. Vertical line test. Big, fat fail. Where can we see it failing the vertical line test? Let me see. I guess I'll use purple, because purple is the relation color, so this might be a little dark, this purple, but here's a vertical line. Okay, don't really need those arrows, but here's a vertical line. Slice them right through there. By crossing multiple x's, don't you see right here? -3, -3, -3. The x value of -3 goes to -1, 1, and 3, not a function. Why not? Oh, well, whoops, there's my reason. Domain, just -3. Range, we have a little bit more going on in a range. The range is -1, 1, and 3. Here, doesn't look like any x repeats itself. I know we don't know what a, b, and c are, but when we use letters, we're usually representing distinct constants. So from what I can tell, I'm going to say yes, okay? Unique x values or unique input values, whatever you want to call them. Domain, unique means original, right? And then repeated, A, B, C. And then range is D, E, F. I know you don't really know the smallest or the biggest, but we default to alphabetical order in a situation like this. Here, all right, domain. I'm going to go back to my colors I used on the page before because I feel like I haven't used them. Domain is your x values. You need to look at them to tell if it's a function or not. So that's my domain. So is this repeating? No. So maybe I start with domain this time. 0, pi over 2, and pi. Pi is a number. You can have it in your domain. Yes, it's a function. Okay, all original input values. All original inputs. Nothing's repeated. And then range. So range, we were using blue. I know it's going to be a little heavy, but we have 1, 0, and 0. So how do I write that? 0, 1. Again, similar to practice problem 1, a y value could repeat itself, or an output value could repeat itself, and it could still be a function. It's all about the x's. Last, we have another mapping diagram. Input, output. Is this a function? Yes. Okay, each input pairs with exactly one output. So if you notice, I wrote it differently every single time. Domain, least to greatest, I have 10. I have 19 and 20. And then output, I have 1 and 6 for my range. We're done with that. So a little bit more of an explanation of this vertical line test. So I kind of sampled it over there. Again, we already learned this. This is us just reviewing. Use a vertical line test to determine if a relation is a function. The vertical line test states, if a vertical line passes through more than one point on a graph of a relation, then the relation is not a function. So if a vertical line, and now I'm doing this part in purple because we're really describing non-functions right now, then the relation is not a function. Well, how can you kind of spice up that sentence and change it to describe what has to happen if it is a function? If a vertical line passes through no more than 1 point on the graph of a relation, then the relation is a function. So again, what changes? If a vertical line passes through, in there, I'm drawing an arrow, and over here, acknowledging this as well. So how would I change the definition? I would have no more than, ... And then we said the word not will be crossed out. Is. Okay? Hopefully that makes sense to some of you. What methods can be used on sets of ordered pairs, mapping diagrams, and or table of values? Describe in detail. So we just talked about that. Table of values, just look if x is used more than once, not a function. If they're all unique, you're good. Set of ordered pairs, same idea. Check your x's. And mapping diagram, if an x or an input has more than one arrow coming from it to the outputs, again, make sure on a test or quiz when you make your own mapping diagram, use arrows like this, pointing to the right, and label your unique groups, your input and your output. Okay? So make sure you're aware of that so you can move quickly. All right, last thing that we're going to acknowledge right now, I'm only going to do the first 4 with you. We are going to do some blank notation practice. Hopefully you can just tell by looking at the pictures what kind of notation I'm talking about. I am talking about interval notation practice. So we've been finishing and fixing out, working on those inequalities. And the inequalities, I have to keep constantly asking you guys to make sure you're taking full notes, okay? The inequalities, we ended up drawing on a number line and then writing in interval notation. We're going to do the same thing sort of here, except instead of it being a one-dimensional graph, only being on the x-axis, we have a two-dimensional graph, okay? It is on an x and y plane. So I have these graphs over here. I'm just kind of tracing over the graph portion in color to kind of highlight them a little bit. So I have a few different shapes going on. So the questions we're answering on this page are, determine if the given relation is a function. These are still relations. Relations are relationships between inputs and outputs, two sets. Determine if it's a function. We just talked about vertical line test. We're going to use that. Describe the domain and range with the most appropriate notation. So set builder notation is not appropriate for this. See the difference in what they look like? Very different. So is it a function? Looking at all 4 of these. Take a second. Are any of them not functions? Are any of them definitely functions? Which ones are or are not functions? I'll give you a few seconds. The answer is yes, this is a function. Yes, this is a function. Number 11, yes, sorry, that y does not look like a y. Yes, that one is a function. And number 4, where's my 4? Well, the 4th one here. Number 12, yes, all of them right here are functions. Next, domain. From left to right, you could still think of it as being on a number line. The red pen is overlapping my graph, right? I don't know which way to really describe it to kind of change up how we look at it, okay? But if you thought of the red pen as where, if it got pulled to the closest x-axis, where would it be? So the one on top would pull down, the one on bottom would pull up, and it's here now. The arrows at the end tell me it would go on and on forever. My whole x-axis or my whole number line would be colored. So what domain do I have? My domain goes from negative infinity with a parenthesis because we start all the way down there at negative infinity. We can never get to it, so we use a parenthesis, comma. Okay, this is not an ordered pair. This is not the comma and set builder where you're listing x's or y's or whatever. This is telling us from negative infinity until infinity. You read it differently because it's interval notation. How about the range? Well, the range, same thing. If I had to kind of magnetically pull my graph to the nearest y-axis, The one that's on the y-axis would stay where it is. Everything else sort of pulls in, and it's going to go up and down forever and ever. So negative infinity to infinity. Now, I kind of want to label up over here a little bit. I'm going to go ahead and label this as a linear. We just said it is a function, so we can call it a linear function. Next, other graph right here. Domain. Now, all of this has to pull in towards the closest x-axis. Domain goes with x. Everything down here is going to pull in and grab onto this. Everything up here, go to the nearest x-axis, it's all going to pull down. All of this is all going to pull down. The arrow goes this way forever and that way forever. So your domain, again, is negative infinity to infinity, also known as all real numbers. Range. We're going to go to the nearest y-axis, directly there. Nearest exit, kind of like an emergency, right? Nearest y-axis. This piece goes right up against there. This all moves against here. That, all against there. So my range, the lowest y value, is -1. I'm going from the bottom to the top, comma, up to the top, forever, infinity. I have a bracket because -1 is included, okay? Do not overestimate your ability at this. A lot of you struggle, so pause, try on your own, and then come check, okay? Oh, but before, let's label this one. You don't really know this function that well right now. Maybe you talked about it in Algebra 1, but it's called an absolute value function. We will speak of this more. So you're pausing and trying these on your own and coming back, okay? I'm assuming you tried on your own. So domain, this is referring out that way forever. This is going out that way forever. If it pulled to the nearest x-axis, it's going to pull that way, and it's going to pull that way. This will all pull here. So all the x-axis, again, the domain is negative infinity to infinity. It's very easy to start understanding this once you get to an example that isn't negative infinity to infinity. I mentioned that at the beginning of the year. You really want to be able to find what is something and what is not something, okay? Range. The bottom goes down forever, so I'm coming from the depths of the y's, which is negative infinity, and I go up, 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 up until when? 1, 2, 3, 4, 5. 5 is the highest value. That is a vertex. That's also a vertex. Your vertex points are very important. It's included. You do touch it right there. What kind of function is that? That's actually called a quadratic function. You may know that graph is a parabola. All right, this one you should have tried already. Domain is not all real numbers. It starts right here. All of this would pull in towards the x-axis that way forever after that. So what's this? 1, 2, 3, 4. -5, comma, infinity goes to the right forever. And then the range, okay, it does go down forever, and it stops going up at -2. So it comes from negative infinity until -2. If you have to turn your paper to do your range like this, where your positive y is on the right and your negative y is on the left, then do it. Negative infinity until -2. Okay? So what did I do? I rotated the paper. How many degrees and which way? I rotated it 90 degrees clockwise. If you have to rotate your paper 90 degrees clockwise to do the range when you're doing it from a graph because you're better at domain, then do it. Okay? So what note can we write over here? Maybe put a little star by range. You can write rotate paper 90 degrees, which is a right angle, clockwise. Clockwise. Okay? Now, what kind of function is that? I know you don't know it just yet, but this is going to be called, you'll learn it later, it's a square root function. So what I want you guys to do is try the next 3 on your own, and any other worksheet I have for you, you're going to just give that a shot and get that done. Or maybe it'll be online, Google form or a Quizzes, okay? So you're going to check on Google Classroom for the rest of your assignment, but you're definitely doing these over here, okay? And if not already, I want you to kind of read through this and see if you can evaluate these functions. Please, please, please use pencil, okay? Because we make mistakes and I want to be able to fix them. But first and foremost, these 3 examples, and then check Google Classroom for a practice, which will probably be practice similar to the ones we just did. I know they're worked out on my other page. The ones we just did over here. All right? See ya.